Okay, two quick things before we get started. First, I highly recommend making notes as you watch the video. The stuff can get overwhelming really quickly, especially if you have not seen this type of content before. Second, if you would prefer this lesson in written format, the notes for this video are completely free in the description below. I recommend reading the notes and watching the video for clarifications, or watching the video and then going back to the notes for clarification. Whatever works best for you. The examples I use in the notes and the video are completely different, so you get the variety, but the content is exactly the same. Okay, hopefully you have your notes set up, whether it's iPad or paper and pen, whatever works best for you, and let's get started with the video. Welcome to your first LSAT lesson. In this video, we will be going over conditional reasoning. Conditional reasoning is something that is going to show up time and time again, especially in the logical reasoning section. So we are going to spend some time developing this foundational skill before touching real LSAT questions. Let us begin with the definition. Any statement that can be boiled down to a simple if-then structure employs conditional reasoning. So for example, if someone votes in the federal elections, then they are a registered citizen. Now, first of all, I hope this sentence makes intuitive sense, but more importantly, we know that this statement uses conditional reasoning because of the if-then structure we have going on over here. Every statement that uses conditional reasoning has two parts. The if part, oh, that is not what I wanted to do. Okay. The if part, which is called the sufficient condition, and in this example, voting in the federal elections is the sufficient conditions. And we also have the necessary condition, the then part, necessary condition. And in this example, being a registered citizen is the necessary condition. Let us begin by discussing the sufficient condition in a bit more detail. Whenever the sufficient condition is true, the necessary condition automatically follows. So let's say we have John over here, and John comes and tells you that, hey, I voted in the federal elections. You don't need John to tell you that he's also a registered citizen. Why? Because of this property we have going on over here, that we know that the sufficient condition of voting in the federal elections is true. So the necessary condition is also going to be true. So you don't need John to tell you that he's also a registered citizen. But when the sufficient condition is false, we actually cannot conclude anything about the necessary condition. So let's look at this example real quick. We have Rob and Alice here. In both cases, the sufficient condition is going to be false. So both of them did not vote in the federal elections. Rob is an international student, so obviously he's not a registered citizen, and that's why he cannot vote. So this makes sense. But Alice is a citizen who just chose not to vote. We all have friends like Alice's. They may not be really good citizens, but they're citizens nonetheless. So in this case, she is a registered citizen. So notice, in both Rob and Alice's case, the sufficient condition is false. But in Rob's case, the necessary condition is false, but in Alice's case, the necessary condition is true. And because we have this ambiguity, we cannot conclude anything from the fact that the sufficient condition is false. So if someone comes and tells you that, hey, I did not vote in the federal elections, you cannot conclude anything about their citizenship status. Okay. Let's move on to the necessary condition now. And the necessary condition works in reverse. So here's what I mean. When the necessary condition is true, you actually cannot conclude anything about the sufficient condition. So let's take John and Alice. We know in both situations that the necessary condition is true. So they're both registered citizens. But John, being a good citizen, actually voted in the federal elections, but Alice just chose not to. So notice we have this ambiguity over here again. In both situations, the necessary condition of being a registered citizen is true, but in John's case, the sufficient condition is also true, but in Alice's case, the sufficient condition is false. So once again, if someone comes and tells you that, hey, I'm a citizen, I'm a registered citizen, you actually still cannot conclude anything about did they actually vote or not. They could have, or they could have simply chosen not to. But when the necessary condition is false, the sufficient condition is also false. So let's take Rob's case. And Rob comes and tells you that, hey, I am not a registered citizen. In that case, you can say something about him voting in the federal elections or not. You automatically know that he did not vote in the federal elections. Because whenever the necessary condition is false, the sufficient condition is also false. Being a registered citizen is the necessary condition, and we know it's false because Rob comes and tells you that, hey, I am not a registered citizen. From that, you can conclude that he must have not voted in the federal elections. Okay, now life is not going to be that easy on the LSAT. Life would be too easy if every time the LSAT used conditional reasoning, you had this nice if-then structure going on over here. Because the LSAT uses multiple words and phrases to indicate that conditional reasoning is being employed. So here are the keywords for the sufficient condition. We already know that the if is a keyword for the sufficient condition. If someone votes in the federal election, then they are a registered citizen. But something like all the people who vote in the federal elections are registered citizens. This is saying the exact same thing. It's saying that voting in the federal election is a sufficient condition. Same thing with every, any, so on and so forth. By the way, if you want this table in written format to study better, just check out the notes in the description. I use a different example there, so it's hopefully going to help you click if stuff is a little confusing right now. So, okay. Same thing with then. So we already know then is a keyword to indicate a necessary condition. But we have other phrases as well. So only if is also used to indicate a necessary condition. Only when, requires, depends on, necessary, so on and so forth. Once again, check out if you want this table in written format, just check out the link in the description. Okay, so let's move on. Yes, so the order also does not matter. So in our classic example, so we always, let's look at this if-then structure, we always place the sufficient condition first and then the necessary condition. But order does not necessarily matter. It's the key word that matters. So here we have only if, and we know that only if is an indicator for necessary condition. So everything that's attached to the only if becomes the necessary condition. So being a registered, oh, that is not what we want. There we go. Being a registered citizen is the necessary condition. And every time, you have a necessary condition, you will always have a sufficient condition. Like for a statement to use conditional reasoning, both parts must exist. So since we have a necessary condition, which we have identified from the key phrase only if, we know the rest, voting in the federal elections, is the sufficient condition. So sufficient condition. Excellent. Now, because we have so many things going on over here, right? There can be so many different keywords and key phrases to indicate the sufficient and the necessary conclusion. Even the order does not matter. We need a way to simplify conditional reasoning, and this is exactly where diagramming comes into play. So, all conditional reasoning statements can be diagrammed. And the way we are going to diagram is as follows. It's A, an arrow, and B. And you read this as A implies B. Where on the left-hand side, A's side, A is the sufficient condition. Then we have an arrow, which we are going to call implies, and B, which is the necessary condition, is going to be on the right. And you read this once again as A implies B. So let's diagram the running example going on over here. So we already know that voting in the federal election, actually let's take one step back. We read this and we identify, hey, this is the sufficient condition because of the if keyword, and we know that this is the necessary condition from the then keyword. So, following our rules, placing the sufficient condition on the left and the necessary condition on the right, we're going to do just that. And we strip off any keywords or phrases. So we're not going to include the if and the then in the diagram. So this becomes voting in the federal election implies they are a registered citizen. Okay. And check out the power for the power of diagramming. So let's use this example. So in this case, the necessary condition is first, followed by the sufficient condition. And we know that because of this only if key phrase here. And we follow the same rules. So the necessary condition always goes on the right. So being a registered citizen is here, and we would place it on the right. Everything else is the sufficient condition. And we would place it on the left. Same thing with a statement like this. Every person who votes in the federal elections is a registered citizen. Notice how every is a keyword for a sufficient condition. So we know that everything attached to that would go on the left because it is the sufficient condition. And when we have a sufficient condition, we also have a necessary condition. And we know this would go on the right. So notice 3 different statements. 3 different keywords and key phrases used to identify the sufficient and the necessary conditions. The same diagram. So this is how we can generalize any conditional reasoning statement. And in the next video, when we are going to learn how to chain multiple conditional reasoning statements and do inferences from those, diagramming is going to be essential. Okay, let's build more on the sufficient and necessary conditions. So sometimes the sufficient or the necessary condition might have an and or an or in it. And those work a bit differently. Well, they work the exact same way, but we need to just build upon our knowledge so far. So let's say you have an and statement in the sufficient condition. So for example, if someone voted in the last federal election and have not given up their citizenship, then they are registered to vote in the next elections. Okay. The way we would diagram this is as follows. So we identify the 2 parts, which in this case are separated by an and. So voting in the federal election is one part. Not giving up your citizenship is the second part, and we're going to include the and in our diagram. We have our implies arrow, and every time you have a sufficient condition, you have a necessary condition. In this case, you have this nice then keyword to identify it, so we know everything else is just going to go on the right. Now, for an and statement to be true, all individual parts of it must also be true. So let's say we have Rose. And Rose comes and tells you, hey, I voted in the last federal elections. You cannot conclude that she is registered to vote in the next elections, because what if she gave her citizenship? Remember, we have an and in the sufficient condition. The sufficient condition is not true if Rose just tells you that, hey, I voted in the last federal elections. But if she comes and tells you, hey, I voted in the last federal elections and I have not given up my citizenship, then the sufficient condition is true, and we have our original rule that we learned all the way here, that whenever the sufficient condition is true, the necessary condition is also true. So in this case, if Rose comes and tells you that, hey, both of this is true, the sufficient condition is true, and then you can conclude something about the necessary condition. In this case, that yes, she is registered to vote in the next elections. And if she explicitly says that, hey, I have given up my citizenship, well, in this case, the sufficient condition is false, and you cannot conclude anything about the necessary condition, right? So for an and statement, both parts must be true. And if there are more than one parts, let's say there was like and, I don't know, something else, all 3 parts must be true. Self-explanatory. So all parts of an and statement must be true for the whole statement to be true. Okay. Let's erase this and move on. So if an and statement is in the necessary condition, so we have an example right here where we have an and statement, and notice how, oh, that's an R. There we go. That's an and. Only if a person is an adult and a registered citizen are they eligible to vote. So we know only if is a key phrase used to indicate a necessary condition. So everything that is attached to only if, so in this case, this and this would go on the right-hand side. Since there's an and, since there is an and, we would put the and in the diagram as well. And every time we have a necessary condition, we also have a sufficient condition. In this case, it's being eligible to vote. Now, the same thing applies. If Bob comes and tells you that, hey, I am eligible to vote, so the sufficient condition is true, the necessary condition is also true. But in this case, the necessary condition is an and. So you not only you know that the necessary condition is true, you know that all parts are individually true as well. Because for the classic rule applies. Sufficient condition is true, the necessary condition is true. And when an and statement is true, like in this case, individual parts of it must also be true. Okay, now let's look at the flip side, the or. And for an or statement to be true, at least one part of it must be true. So, for example, if a person has a valid government-issued ID or a witness, then they are eligible to vote. So, we have an or, and we know that this uses conditional reasoning because of the if-then. We have two sufficient conditions here, separated by an or. And we have the then here to mark the necessary condition, so nothing new so far. And Chris comes and tells you that, hey, I have a valid government issued ID. Let's use red for this, yeah. Well, in this case, for an or statement to be true, you only need at least one part of to be true. So yes, if he has a valid government issued ID, the sufficient condition becomes true, the necessary condition follows. He may have both. That's still fine. The sufficient condition still remains true, and the necessary condition follows. And if he says that, hey, I don't have an ID and I don't have any witnesses, the sufficient condition becomes false, and once again, we cannot conclude anything about the necessary condition. And if we have an or in the necessary condition, so let's look at this example. All good citizens, there needs to be an S, but it's okay. All good citizens either vote. Okay, that's even more ugly. Okay, all good citizens either vote or serve in the army. We know all is a keyword for sufficient conditions, and we have good citizen. Amazing. So we put that on the left. Everything else goes on the right. And it's separated by an or. Okay, let's use this. Excellent. So George comes and tells you that, hey, I am a good citizen. Excellent. From this, you can conclude the sufficient condition is true, so the necessary condition is also true, so you know this part is true. But remember how any one part of an or statement must be true in order for the whole or statement to be true? In this case, there is no way for us to know that did George vote or did George serve in the army, right? Because he could have voted and he could have not served in the army. The necessary condition is also true. And that's all we can conclude from George being a good citizen. It could be the opposite. It could be this, right? No way for us to conclude that. Or it could be that both happened. No way for us to conclude that. So all we can conclude in this situation that George is a good citizen. He either voted or could have served in the army. Like, there's no way for us to know which exactly. Okay, one last concept before we wrap this video up. The contrapositive. Let's have this standard diagram. A implies B. And the contrapositive allows us to flip the order of the sufficient and the necessary condition. And in order for us to flip it, so you can't just flip it
like this. Like this is wrong. So if I write it like this is just like absolutely wrong. No, bad. Never do this. This is saying a fundamentally different thing. The contrapositive, on the other hand, allows us to switch the sides, but in order for us to switch the sides, we have to negate the sufficient condition and the necessary condition. And we're going to spend quite some time on negations in the next video, but for now, negation just means let's just add a not, okay? It's not as simple as this, but for now, it's gonna be sufficient for understanding the contrapositive. So we add a not to negate. So the diagram, the arrow is still going to be there. In order for me to move A on the right-hand side, I have to add a not. So this becomes not A. And similarly, to move the necessary condition on the left, I need to negate it. So it's going to be not B. This, both of this, so let's just remove this bad diagram because never do that. It's wrong. But this and this are saying the same thing. They are logically equivalent. So let's try this with an example. So we have the classic, if someone votes in the federal election, then they are a registered citizen. What is the contrapositive? Well, I switched the left and right side and negate each side. So this becomes not a registered citizen implies did not vote in the federal elections. And a question might come, why are we learning the contrapositive? What's the point of flipping these two things around? And it's all going to make sense in the next video when we do some chaining and inferences. So hold on to that. Let's just understand our basics first before we start applying these principles for the LSAT. Okay, two more quick things before I end the video. To really explain to you the power of diagramming and why the contrapositive works the way it does. So the diagram also visually captures the first couple rules we learned. So the first rule we learned is when the sufficient condition is true, the necessary condition follows. So the first diagram just says that visually, because if this part is true, we just follow the arrow, and where does it lead us? It leads us to the necessary condition, and that's why we say the necessary condition is also true. The second rule was when the sufficient condition is false, we cannot conclude anything. Where, let's see where the sufficient condition is false. It's right here in the contrapositive. And notice how there is no arrow that's going outside. Like there's an arrow pointing towards it, but there's no arrow pointing from the false sufficient condition. And visually, this basically says that we cannot conclude anything about the necessary condition. Similarly, when the third rule was when the necessary condition is true, we cannot conclude anything about the sufficient condition. That's captured right here. Once again, notice there is no arrow that's pointing from it, so we cannot conclude anything about the sufficient condition. But when the necessary condition is false, which is right here, we actually can conclude that the sufficient condition is false. And visually, we can see that there is an arrow that's leading out towards the false sufficient condition. So diagramming is super powerful, and using the contrapositive and the original diagram, moving between these two are going to be fundamental skills that we will be using over and over again on the LSAT. Okay, hopefully the lesson was not that bad. I highly recommend you to go practice now. I've created 2 problem sets for you guys. Each problem set is about 25 questions long, and it covers everything we have learned in this lesson. So go do the first problem set, see which areas you're still struggling with, review those areas either from your own notes or come back to this video or review my written notes, whatever works best for you. And then go to the second problem set, which has a fresh set of questions. And both the written notes for this video and both problem sets are completely free, so use them as much as you want. And while we are not solving real LSAT questions yet, we're going to save those for when we start learning the different question types and learning the different strategies for each. We don't want to waste them for something like conditional reasoning. The interface the problem set uses is going to be the exact same interface you will be using to practice real LSAT questions. So
another great use of these prompt sets is to get used to this interface. So go practice, and I'll see you in the next video. Thank you.